So let's look at the quick way of determining the hybridization on an atom without going through what we did before. Once again, what we did before is still important, but we can explain it more when we meet. Now, here's the quick way of doing it. What you need to remember is that a lone pair, a double bond, a triple bond, or a single bond are all electron domains. So they're all electron domains. So all you have to do now is determine the number of electron domains, and that is called the steric number. And once you have that number, then you can determine the hybridization. So if you end up with 4 electron domains, then that would be sp3, s and 3 p's, 4. If you end up with 3 electron domains, then that would be an sp2, 1s and 2 p's, if you want to break it down. And if you have 2, then that would be sp, s and p. So once again, a single bond, a double bond, triple bond, and a lone pair, those are all electron domains. So this is 1 electron domain, 1 electron domain, 1 electron domain, and 1 electron domain. You can think of, if you would like to replace the word domain with a group, that's fine. An electron group is 2. It could be 2 electrons. An electron group could be 6 electrons. That's the triple bond. But you have to remember it's 1 domain. Okay, so we just did this one right here. And we found out that it was sp2. Well, let's look at the hybridization on one of the C's. So let's look at it. Let's determine how many domains or electron groups are attached, or it has. Here's one domain, that's a single bond. Here's one domain, that's a single bond. And a double bond is also another domain. So our steric number here is a 3. And we said 3 corresponds to what? An sp2. So the hybridization on this C is sp2. Here's another one. The hybridization on C, let's count how many domains. Here's one domain. There's another domain. So that would be an Sn of 2. Remember, a triple bond is only one domain, electron domain. So let's look at what 2 stands for. Well, that's sp. You can do the N as well. Count how many domains it has. Has 1, that's a lone pair, and it also has that triple bond. So even the N has 2 domains. So that's also sp. Now, okay, let's look at this C here, any of them. Of course, they can be attached differently, but let's look at this C, for example. This C has 1 domain. Let me erase the first one so that you don't confuse it. 2 domains, 3 domains, and 4 domains. So that's Sn of 4, which corresponds to an sp3. Now, I would like you to add the angles because it's always true. anytime you have an sp3, the angle is going to be 109.5. And we know that that's a tetrahedral. So they go together. So you don't have now, you can kill two birds with one stone if you remember that an sp3 is also 109.5, which is tetrahedral. If you have an sp2, that's 120. And we're just going to call this planar or trigonal planar. And if you have sp, that would be 180 degrees, which is linear. So therefore, with the sp2, you can say that's a 120-degree angle. With the sp, that's going to be 180. With sp3, that's going to be 109.5 and a tetrahedral.